I'm really honored to be here and to have such a big turnout. I've been involved in natural farming for at least 8 years now, and to see this much momentum and how we've really sown the seeds over the years and collected our beneficial microbes and fed them enough sugar that now they're starting to multiply, and it's fun. It's like a party, you know. It's like a adventure. My goal is here right now is I have a presentation. It's 26 slides. So, formulating CGNF Hawaii natural farming solutions. This all comes from Master Cho in Korea, Han Kyu Cho, which is the Cho Global part of our natural farming. So what this comes from is, as you may have all seen, is that the natural farming comes from pigs. So when you look at natural farmers and you're like, why are these people so cool? It's because they hang out with pigs a lot, and pigs are really mellow, great animals that are great teachers and very patient with you to teach you a lot. And so natural farming, I started out with this, you know, we kind of always start out with a philosophy part to kind of say, because it's kind of different how you approach it. You're not just going and putting A with B with C. You're kind of thinking about these systems and really understanding why you're putting A with B with C and not just going A to C. You know, all these steps in between are important. And so when we observe nature and we kind of start with this philosophy, and one of my main philosophies is trying to get out of the way. You know, it's a classic Eastern, like, get rid of your ego type of thing. I'm trying to get rid of my ego in farming, so natural farming's compatible of, you know, think about, I farm for the microbes. The microbes do my farming. And that's a great way to crush your ego, because then you're just kind of helping your friends out, and they're responsible for what's happening in the ground and in the soil. And they do a great job if we support them. You know, microbes can make or break us. You know, it's either a plague or it's abundance in a healthy ecosystem. And I try to provide enough food so that it tends towards that healthy ecosystem. More food, happier microbes, happier macro world resulting from this micro healthy health that I've created. I also put up here about the field. Someone earlier mentioned the matrix, and it's kind of this idea of like this field that we're all in. I like it. Not only do we farm in a field traditionally, but you also create energy fields and microbe fields and vibrational fields out there. And so we want to make sure our field always has enough food to invite beneficial microorganisms. So fungus and bacteria and those things. And it's a function of food in our field. So whether that's on your body, it's in your animal, it's in your actual, what we call fields, enough food out there is what you need to do. And how to judge the right amount of food. I love metaphors. So I find metaphors really good for teaching. If you can think in these metaphors, it makes it common sense. So I was thinking the other day about, you know, I was watching this documentary on this guy who just puts out wood chips. That's all he does. It's called Back to Eden. It's a great video. He just puts out wood chips. He stopped tilling the ground. He stopped doing all these things. And the only fertility thing he does is wood chips. And I watched that and I thought, wow, you know, that's genius. Why are the wood chips doing it for him? Why are they providing all the fertility he needs? And if you think in nature, only branches and leaves are falling. It's only eating wood chips in nature. And so what he's actually doing is he's really, by putting that much wood chips, he's really concentrating his fungus. And just like when we eat, we heat up and we digest, the same thing when you put that much life out into your soil, it's digesting. And you can think of that as a low burning fire. Just like your digestion only raises your temperature a few degrees, same with this. You know, it's not more than 120 degrees out there. You know, that's incredible. It must be a really rich source. Usually it's happening at like, you know, almost at what we consider ambient temperatures. So if you think of it as a fire and you always put enough wood out there to keep that fungal little burning fire happening. And obviously, if you put too much at once, you'll smother your fire and you'll kill it, and you'll kill that. And if you feed it just at the right amount, then it's going to give you a nice heat that's going to be consistent. You don't want to grill with a fire that's really hot, and you don't want to grill with something that's too cold. And so when you adjust your amount, Mahalo, thanks for that, getting rid of the feedback. Feedback can be good in some instances. So this low burning fire, I really like to think of that, because then I'm now feeding, I'm not looking and saying, are my plants hungry? I'm looking at my field to burn this fire of these microbial interactions that are then creating the heat to cook my garden. So again, that's that step back of my microbes are in charge, and I'm that second step. And I put this warning in here at this last point on this slide, which says there's always cheaper versions of natural farming. It's happening naturally outside with nobody doing it. So it's free. There's always cheaper versions, but CGNF Hawaii, the recipes that we've kind of gotten here, the instructors that you've learned from today are of the highest quality. And Derek spoke this morning, he said, keep the quality high. And that's what we're trying to do. You can rot something in a bucket and, do something like that. That's cool. But what we're doing here is the highest quality of ferments, and really finding where that is, adapting it to our local, restrictions here, and adapting to that. But I always try to aim for the highest quality. I've learned from a bunch of people. I'm always learning from every source of people that just take manure and put it in water. And I'm like, I'm just thinking of all the nematodes and stuff going crazy in there and all the pathogens in the water. And I'm like, but I always learn something from seeing people's approach to this. And this approach that we're presenting here just happens to be one of the highest qualities. In all of my experience, I've never seen one and been like, wow, that's better than Master Cho had kind of given to us. These are the best. Sometimes you can't afford it, but do, get there. And then these are the highest quality. So just to let you know, where can we use natural farming? Everywhere is the answer, if you cannot tell from that list. But I enumerated a few out just to just show you that I think in the family garden is the #1 crucial spot. I see as we return to more local food production in our own yards, you can make all your own fertilizer at home with sugar. You can put this out into your yard. You can get your compost. You can get this little miniature cycle of natural farming happening in your family garden. And like I said, this transformation's from inside. Now you've got this revolution going because you don't go to the, you're eating healthy, and you got so much abundance, now you have to share with your neighbor. So family gardens, #1 spot to start. Learn. Commercial operations. We're getting natural farming into commercial operations as we've done more research to get university support. We're at the university right now. So this is the switch of recognizing microbes as our answer. And as we get the documentation that when you enter into a commercial thing, you now have a bottom line. It's not like, oh, my pumpkins didn't work. It's like, no, now my business needs this steady supply. And so natural farming can provide that. And we're working to really provide that support infrastructure under that, so that, today you can go ask about, at the university, and we're trying to bring that in here so you can get that information on natural farming. I put up these rough estimates of $175 an acre a year and $100 an acre a year for a vegetable and orchard. These are just, if you're gonna go do the maintenance spray, this is like a Richard Perea type budget of what he's spending. So it's not quite like Master Cho level, I did all my IM14 and I got my OHN and I got everything perfect. That's probably not this price point, especially your first year. It may be your second and third, maybe 2 to 3 years in, because when I went to Korea, I noticed the farmers that were in natural farming longer did less. They were happier and they did less because they set up that foundation. The microbes are working for them. They just come back with a little bit of foods for $75, spray their thing, and they got this foundation that's 8 meters of soil fertility that they didn't have to buy and bring from someplace. Now they activate it, 8 meters. So they spray a little bit, you know, and so you can really get your costs down the more you treat your living soil as a, you know, a friend. I put up here remediation of damaged lands. IMOs are notorious for eating oil, for eating radiation, for eating bad smells. They can clean up almost any waste site, especially combined with the Korean natural farming of putting the sugars with the plant juices, with the, like we were learning about. It can clean up almost any damaged land. You know, there's stories of farmers, Ginger John, blasted land, puts IMOs, worms return. Fertility is back. There's a story of me going down to downtown Hilo, was herbicided for decades, come into that triangle, put IMO and biochar, coconut husk, thing, just, you know, super abundant. So this can heal all damaged land. I put up hydroponic, aquaponic systems, because I believe any of those things where it's synthesized chemical type stuff, we can do those same things naturally through fermentation. So it can replace all your inputs. I haven't personally grown that way, but I'm sure I could, you know, it's pure food. It's the same idea. I also put up here growing in pots, because, you know, some people just, you know, start a little rosemary plant and start natural farming it, and, you know, anywhere it'll work from any scale is what I'm trying to show here. And I left this little bit. These, you can kind of see I like prototyped this slide as I was building it, and I left in the show balance sheet, yearly production, how what costs, because that was kind of a note to me of like what I wanted to put in here on this slide. And I wasn't able to put that into the presentation in a way that was, because there's so many unique cases, like I have this, I'm growing tomatoes, I'm growing that, you know, so, but what I do have is a spreadsheet on my iPad that I'm happy for any size acreage or whatever. You tell me what you got, I'll plug some numbers in and get you a cost benefit, you know, like in, you know, iPad seconds. So I want to bring that is available. We know the costs. We know manufacturing things. They're getting cheaper as more of us get into it. Like there's all of us here, you know, that they're getting cheaper. On the left side, the picture is my keiki making a fermented plant juice, but look how happy they are because they get to lick their hands after they're done. And they're like, they pull out chunks of sugar this big from the bag, and they're like, can we have this one? I'm like, no. Break it in half. So what I wanted to do is, you know, everyone was talking about like co-op and label and like make a group and do all this stuff. I've been in this for a while. CGNF's kind of been part of what we're doing. I have this sweet little graphic up there. And within this CGNF, I think these systems that I have listed here pretty much give us a standard thing of, you know, if you follow these recipes, you'll have everything you need to be effective on a farm. And then there's other things, you know, like, you know, someone's like, well, I fermented this, you know, like Richard today had his Christmas berry tincture done with alcohol, which that's not in our list, right? But that's compatible in a way, and you know. And then if we block out with these to say, okay, we got these solutions that natural farming offers, and then you can have additions into those, then that gives us a basis to work off of. And this is what I've been taking a lot of my time and energy to really try to solidify is, what do we call these things? Because forever we've called it fermented plant juice, which I take the plant and I ferment it and I get juice. So that describes a process, right? What I am calling them is that same thing you call the fermented plant juice, I'm calling it a plant food. Because now I go to use it, how do I use it? Well, plant food, I feed my plants it. But a fermented plant juice, what do I do with that? I don't know, it's a fermented plant, you know, so what I've been doing is trying to get our vocabulary to match our usage. Because when this came from Korea, it came as how to make it. So fermented plant juice, fish amino acid. They don't tell you like, okay, this is plant food, this is a DNA booster, this is gonna make it flour. And so naming it by the uses is what I'm trying to bring in here. And so I got some people closing their eyes here, and I'm an elementary school teacher, and I love to be upbeat, so I will enunciate a little better and get some energy going, because I was kind of droning on, right? Didn't that feel good? All right, so I got these things up here. I just wanted to show you this slide because this is going to kind of contain the next couple slides of what I'm going to go through. You see I got life establishment formulas, plant maintenance solution, and maintenance enhancements. I'm going to go through those three and make them as exciting as I can. So before I get to that, something for everyone, because I talked about cost. Everyone always tells me natural farming is too expensive. Something for everyone. What can everyone afford? A trip to the ocean. I guarantee, well, I mean, some of us maybe not, but 99.9% of us can go to the ocean in Hawaii. And it is full of this brine of minerals that are just free right there. So if you take seawater and you dilute it 1 to 30, so I take 1 part of seawater, so this thing here, and I take 30, which if you see on the right, it equivalates to, if I have 1 gallon, I put 125 milliliters in there, I'm gonna have the same salinity as my blood. Just like when they put an IV into me, it's salt water, tiny bit, same thing. So the salt condition's gone. If you're in Australia, use biochar. But it also now has every element because they all washed into the sea. So I now got this sweet, super mineralized thing. And I have the saline microbes synergistically affect the soil and help to build soil structure. Because there's basically 2 classes of microbes. You got freshwater and saltwater. And when you take the saltwater ones and you combine those with the freshwater ones, you get this diversity that would not occur, 400 feet up from the ocean where my property is. The ocean water would only get up there in small quantities. But when I bring all these microbes, they now bring these guys and they're like, whoa, I've never seen you before. And they create diversity in your soil that we know IMO is all about diversity. That's one of its huge benefits. So when you bring the second family in, you get huge synergistic effects. Also, I know they sometimes use a chemical product on things to before they harvest them, like wheat and sugar and all these things are poisoned before they harvest it to increase the sugar content. And that's crazy because dilute seawater 1 to 15 will do the same thing for you. So instead of using glyphosate, which has chlorine and super bad for your soil, just use a little bit of salt water, which will stress your plant the same way, right, when you're about to harvest it. So it puts all the nutrients, and then the extra salt water makes it sweeter because your tongue loves minerals. When something's full of minerals, you're like, wow, that's flavorful. It's a great detector. So you put the seawater on there, it goes into your plant. And another thing to do is to ferment it for 24 hours with fermented plant juice before you use it. That just increases that potency. Those sea microbes get to grow with this plant juice a little bit, get their extra boost. Then you put them into the soil, and you've got already this active culture going into your soil. So, and my fermented plant juice recipe is down on the bottom. And I'll just let you know, I'm going to put this presentation online. I put everything on naturalfarminghawaii.net, which the URL I think is at the end of the presentation. So seawater, everyone can afford. Now I'm going to get into a couple natural farming solutions. These are how to combine what we learned today. And this first one I was going to start with is just liquid green manure. This is kind of like a custom green grass liquid fertilizer thing. But I've been often asked, what do we do about green manure? And green manure is expensive, mulch, all that stuff's expensive. So fermenting the essence of it out is what this recipe is all about. This is how to make liquid green manure. And so what you do is you take grass, like your weeds, cut them pretty short, put them into a blender with water, and turn it on high and blend it. And now you've got a grass juice. That is what I'm referring to in the recipe down on the right side in red where you see it says grass. It's just one of my things that's a quick, I've just made a blend of grass that, and now I got all that chlorophyll and, whatever weeds you have, like hono or whatever, put them in there, grass, blend that up. Then the other thing I do is I make a starch source. So I take like a cube of kalo in water and I blend it the same way. You can even do the grass and the kalo at the same time in there. But you're just trying to get some simple starch in the water and grass in the water. And the rest of these are recipes that we learned in Korean natural farming. And so there's a lot of acronyms. I'm just going to keep them up there. But you add into it indigenous microorganisms, or IMO. That can be IMO 2 through IMO 4, any of those. You add in and those are your microbes. Then you add in OHN, which is your medicine, right? So this, any interaction that's going to happen there, they're going to have medicine. Then you add FPJ to act as their food. So while they're multiplying in their soil, they'll have enough food to eat. You include BRV, which is brown rice vinegar. Also, I make it from bananas. And we didn't get to that recipe today, but look it up online. Really easy to make vinegar at home. I put it as a solvent. Vinegar is so hard to describe what it does in the soil. It is so amazing. It's a catalyst that helps things digest. Like you can eat twice as many plates of lau lau if you chug some vinegar. So if you're ever going to get in a hot dog contest, put some vinegar in there. Also, if you put a little vinegar in your water in the morning, you drink it, it helps flush you out, right? And so that same thing, it's a flusher. It's amazing stuff. Vinegar cannot, you could say more about it. I could be here for an hour. Same thing about lactic acid bacteria, the LAB. I could be here again for an hour. I called it oxygenators. Richard called them the workhorses. But what these guys do is they keep the environment beneficial to us. If we're not there, you get smells that are not good to you if lacto is not present. When lacto is there, it keeps it beneficial to microbes for us. So it oxygenates as well. And then I'm adding in fish amino acid. Fish amino acid is like the fuel. It's like the gasoline to the fire. It's really dangerous to use, but can get you really good results early. And so we added into this. What happens is all these things synergistically work with each other for about 24 to 48 hours. They create something that's like this. Looks just like regular water, except for when you smell it, you can smell that there's microbes in there. So I have it here. I made it just to show everyone can, not now, but come up, check it out. It's here on the table. It's that middle bucket. This is essentially what I've made here. If you smell it, it smells like chlorophyll, smells like it's active, smells like it's energy. This is going to enable me to very, Richard was all about water and using those things. I tend to think that it's a good idea for us here because water is so abundant. So take this here, now that I've got it fermented, and then this 5-gallon bucket is still diluted out, 1 to 500. So from this 5-gallon bucket, now I've made, that's 4 gallons, I've made a lot, 2,000 gallons, right? So now so it's really potent stuff here. But what you want to do with this is to drench more. It's 100 gallons per acre to really get this green manure in. Because as it ferments for 24 hours, the microbes are going to grab that chlorophyll, which would have been your benefit from having that wood chips and all that wood juice. And the microbes are going to extract it out and turn your starch source into an alcohol. So it binds it in a water-soluble form, and that's why it acts as liquid wood chips. And you think of wood chips laying a layer of mulch on top, but did you hear the story about Vince told with the kalo grower that put the IMO down and none of the weeds grew? By changing the biology to be this fungal, wood-loving, great stuff, the weeds don't want to go there. So it acts as a cover mulch, even though there's no mulch there, because you put the microbes there minus the wood. Like it's this weird concept, you know, like you've done the effect of the wood chips without the wood chips. So this, I put this up here because I believe this to be one of the most affordable ways, and the ways I do it a lot is this right here. I make this kind of tea thing, ferment all these things together. This is what I'm spraying out all the time. This. I do. No, let's go. But however, I am going to move on to the next slide, which is this one. So after our green manure. So I'm going to talk about indigenous field treatment. And this one here is where we do our IMO 4. And so this is like the jet of getting around, you know, like high tech. If you did this, you know, like, you know, I fly economy or something, or in the luggage, you know, this is like first class, like kind of how to do stuff. And so starting with IMO 4, IMO 4 is concentrated fungal spores. I don't know if you got that from outside, but essentially what you're doing is you're taking the stuff from the forest and you're concentrating and like taking their eggs and tuning them to be perfect for your environment, for soil, and then you're putting them out. So it's like taking super soldiers and applying them. And if you don't go to the IMO 4 stage, it's like taking regular people or like, you know, infants. So, you know, there's benefit to going through these stages to get to here. I often can't always afford to go this far. Time, money, lots of reasons. But if you make it and you put 1,200 pounds per acre, I guarantee you will get phenomenal results, assuming you made your IMO right. But that alone is phenomenal. Like the mill run acts as a fuel, the microbes go to work. This alone, the IMO 4 would be good. I then recommend incorporating it with functionalized char. Vince showed the picture of the char, all the mycelia on it. Same thing, when you put this into the soil, the char now gives the microbes a refuge. If you just put the microbes out and conditions get bad, they die. If you put the char out, conditions get bad, they go into the char. Conditions get good again, they come out. Get bad, and so it gives them a home, a safe haven, a persistence in your soil when you add char. I recommend that. Josiah's going to put in a plant here. It's going to get cheaper. I don't know. I put up 125. That was just an estimate of what I thought it might cost. It's functionalized because it's activated with IMO. So don't put out raw char. Always activate it with IMO first. Then I mulch, you know, however much that costs you, if you can get it locally, if you can do it from your own property. Like I said, that documentary, the guy just used wood chips. That alone will get you to IMO, will get you everything you need. And then this last little bit up here is, you see the treatment on the right. This is now a liquid formula that I'm combining OHN, FPJ, BRV, LAB, FA, so many acronyms. I'm combining all these things together, and you can see my reasons for it on the right of why I put them in. Same reasons to the other one of I'm trying to get these components in there. And when I put 1,200 pounds of IMO out, great. When I come back and I water it with this, you know, how do I use those liquids? Now I water it on top. Now all that food is going to go in, and all those microbes are going to start working into my soil. And now my soil is going to aerate and puff up. And so not just putting microbes out, but then feeding them liquid, you know, once a week. This is how to establish like the best soil foundation. If if I was to run like a high-tech operation and you know, had good capital investment, I would do all this, and I mean, you would grow unbelievable produce, assuming you have the market for that, which I just don't have the desire. I like produce with imperfections on it, you know, like what? It's cool. So wait, can you go back one sec? So just to follow up on this, so this recipe here is using all our solid amendments and then watering these liquids on, which the recipe before that was getting all of these solid things in this sort of liquid version, which is why I use it. So do you see the difference between the liquid green manure and then this is more of a field treatment solution of setting a soil foundation? So I just want to make that clear.
What's the dilution that you use for field treatment?
This dilution, I don't ferment this one for 24 hours. I use it straight up, and the dilution is exactly as you see it. There's in the previous, the green manure, I fermented it for a day first, so then I needed to re-dilute it. This one I'm adding in and using it immediately. So this is the product that you're seeing on this one. Does that make sense? Yeah, yeah. So this, that number there, the 164, isn't adding all those together. I summed all those together to say add 164. So that way, the measurements on the right that are in milliliters in the table, for each gallon, I'm going to add that much in. But I also make these, the reason I say those as individual components, and I show these up here as individual components, but really what I want to be able to do is to give one solution, which I'm going to show in the next slide. So this is what I want to kind of simplify the natural farming down, and to take these three inputs that we call OHN, FPJ, and BRV, combine those all three into one thing and call that a solution that is now our maintenance solution. So if you say I used maintenance solution, that implies that you sprayed OHN, BRV, and FPJ diluted in those ratios. Because this recipe right here is a common denominator of all recipes. Every recipe you'll find has all three of these in it. And so let's just call it the maintenance solution. This is the core of natural farming. A lot of these things I'll say just in isolation. If you just use this in isolation, it would be enough. You know, if you just put IMO out as isolation, it would be enough. If you just put wood chips by itself, it would be enough. But when you combine all these together and use the maintenance solution, the whole system is going to start to work. You know, we all eat good food. We all do good work. When we're content and we have what we need, it flows. So this is what I've been bottling and kind of selling. And it's in these bottles that I make here, where this is what's in the bottle. And this gives me a really cool tool, because one 500 milliliter bottle will do 30 gallons of water. So it's nice. I mean, this is a nice thing you can take. You're ready to go. You don't have to measure out your OHN, your FPJ. You just take a maintenance solution, pour it in 20 milliliters per gallon, and you're good to go. And so I try to, make this as easy as possible, that we just talk about, like you did maintenance solution today, because then that's really a common vocabulary for us. Instead of saying, well, I put some OHN and this and that, if we really make it easier for ourselves and say, well, I did maintenance solution once a week, and and then I put IMO out as a soil foundation. I'm starting to name these things by their uses. And then that makes it easier to use for all of us when we talk to each other. So this one here, maintenance solution. It's the core of natural farming. You can use this anytime. Always we say dilute more if you're curious, if you're unsure. I say, this 20 milliliter dilution, but start less if you're, but I spray this everywhere, on the roadsides, everything. So the reason I wanted to show that and kind of make that the common denominator is now I wanted to go into this part here, which is kind of our how you go through the growth cycle. So this is where I think it can simplify natural farming, because all these in common have with them the maintenance solution. So if I look at it any stage of my plant, I can apply the maintenance solution. So if I take that part away and I look at it and I want my plant to flower, the only thing I have to know is, well, flower is water-soluble calcium phosphate, WCP. And so knowing which stage your plant is in and how to enhance it in that stage is the maintenance solution, plus this little amendment, which I'm just calling an enhancement to our formulas. So you're just enhancing your maintenance solutions, because I notice my plants, I just planted them. They're all little starts. So I'm going to add my leaf enhancement into my maintenance solution. Now I'm going to get better leaf growth. So I see my plants starting to put out flowers. Now I'll switch and I'll add my flower enhancement into my maintenance solution. And you'll notice this is the common denominator between all of our things. The one addition I had to this, there's only, so we start with fish amino acid for leaves. We have calcium phosphate for flowers and roots. And then we have calcium to make sweet fruit. I can explain why you'd use those, but they really help the plant at that point to ease into what's happening. So the plant naturally wants to transfer its sugars to the fruit. When you spray calcium on it, it helps that happen. So each of these aids our plants, aids our microbes to help what's happening. So any questions on this slide here? Because this is kind of... so WCA is water-soluble calcium. And we typically made that from eggshells or crushed coral. We did a demonstration outside and we cooked it. It's preferable to cook it. As you cook it, you remove organic matter and leave the calcium behind. And that's preferable because you won't have as much contaminants in your dissolution that you make. Yeah, it helps because coral's living, it's alive. When you cook it out, it gets rid of that living part and just leaves their shells behind. So I put this together as kind of like I think it's a cool label. To stand for quality. I've been working on this with a lot of people, and I believe what Derek was saying of making some unified label, of figuring out our inputs, making all our same solutions, setting this really high quality bar. I've heard, when I was out there, I've heard some of the talking to our audience and saying, we got to. Well, I'm in my small effort trying to provide that with everyone here. And so I think making a label like this where we can stand behind CHO, can figure out, there's solid inputs between, and we can really make this, it's the highest quality. When you eat that, it's like, oh, no poison was on that, this was the best. So that was the first part. I got this little second part because as I was giving this, as I was kind of getting this together, I was talking, and there's still parts of this I need to follow up on, but I was realizing that, I'm trying to teach how to use the inputs, the solutions, how to apply the solutions. But you guys also may need a primer on biology. Because that's what this is all about. I'm up here saying microbes this, microbes that, but what am I saying? Obviously, it's a scientific thing that has a very deep level of study, but as natural farmers, there's some very simple, crucial biology we can learn. So this second part of this little presentation is to talk to you a little bit about the biology and to see the guys we're working with. And to finish my first part is, how do I actually spray the stuff out in my garden, right? So I got this sprayer here, and I had to take off the spray handle, you know, the thing you use to spray, because the thing kept clogging. So now I just use my finger and I squirt, and I use this little 2-gallon thing, and I pump it up and I squirt on everything, right? And I go around and I squirt my garden in the evening. I make these mixes, like I said, right here is one of them. I would take that, put it into my sprayer, go around and spray. I'm soaking my stuff till it's wet, you know, it's dripping. I try to hit the under part of the leaf. But this is a sprayer made out of plastic from someplace, I don't know where. And, you know, like there's a lot of ways to do it, like a big sprayer, like air kind of blowing thing. But I was invited to the Unity Summit, and I got there and the place smelled like urine and feces, and down at the Wailoa Park, you know, that big pavilion. Oh, it smells horrible. So I got there and some people were cleaning the floor with like, you know, orange cleaner, citrus cleaner stuff, cleaning it with brooms and stuff. And I was like, oh, that's all right. So I walked to my car and I mix these mixes up and I spray them on the side of the road from a tank in my car. I flip it on and I spray the sides of the road. And I had a bunch in my car, right? Because I'm cruising around doing that. So I grab some and I put it into this dish and I walk around and I was like, how am I going to spread this? Well, what is this here? This is tea leaf, right? Simple technology, it's been around forever. And I was thinking about it. And why did they used to do that? You know, you go to get blessed and stuff, right? And what happens? They like bless you and they put the stuff on you, right? The juju, whatever the guy had. You know, you're like, thanks, man. But there's a reason to this. There's a reason to this. And I believe that back in the day, we were really in tune with microbes and that, you know, we knew what was going on. And so when you come to go get a blessing, what's going to happen to you is you're going to get the best microbes put on you because that'll start to heal. You know, all of a sudden your skin rash went away. You're like, wow, I feel better. You can digest better. And you're like, wow, this guy did a miracle, right? Maybe he was just naturally farming. But I want to show you something. If I spray with this sprayer here, it's going to put out a trickle and do some things, but it's going to be a little bit like Rocky Horror Picture Show. You ready? Maybe I gotta get a bigger cup. Okay. Stop. So, did you get wet?
Yeah, I got blessed.
So, no, but how did you get wet? Like,
How did I get wet?
well, like, so my point to this is you're not soaking wet, right? What happened?
It was refreshing.
It was misted, right? And really fine particulate size, really small particulate size, really small. And that is ideal for putting out microbes. Ideal. So I think I go around and I'm like, oh, I got to get all this expensive technology. I talked to this guy who's a drone to like fly it up Mauka and like drop all this stuff. And I'm like, cool, I'm going to save the world. And then I think to myself, man, why do I need that guy? I can just get a bunch of friends to walk around with some tea leaf and some microbes and we got it out there better particulate size, better thing. We even put some mana onto it. We got like this whole session going. And this is what they were doing in ancient times. It wasn't just like, oh, here's some water. They were putting microbes out. They had no-smell pig pens. They were doing and using this technology. And we only have fragments of it today of like the guy with the tea leaf, right? And you're like, well, it doesn't really make sense to us today, but when we connect in and we go into this natural farming, there's something. He's putting the spirit, the tiny little lives out there, right? And that's what this is about. So how do I use it now? I do this. I walk around, I get my keiki, we cruise through the garden. I call it Kane Viola, right? Bring the life-giving waters of Kane into our garden, and we spread it around, and we go. And it's fun because with the sprayer, only one kid can use it, right? And I want to be that kid. Then they end up dropping it because it's too heavy, and it's like, so this, now they get the tea leaf, they go with small buckets, they all whip it at each other, they have so much fun. I don't gotta, it's like they're spreading it wherever. Now they go home, they're better immune system, like this whole thing going on. And so I thought, like low tech, like this is simple. We can get hundreds of people, not even like, just me walking out, spreading the stuff, the earth's gonna get better, And so low tech this way, particulate size being fine. I find when I go downtown and I was using the sprayer to spray, people were into it, but I walk downtown with this stuff, people are like, what are you doing? Yeah. So, plus tea leaves grow everywhere around here. I recommend the green kind, they got good stems. Advertising tea leaf. They also make good lays. I don't know if you noticed. But very, very useful. So that's ultimately how I do it. I kind of get down, I try to bring natural farming into my life in the most low stress way possible. Because it's better for me, it's better for the microbes. I love to make ferments. I've been getting into it lately. I think I want to go on a fast where I just drink fermented plant juices from different types. Still haven't gotten to that level, but I got a whole bunch now, collection of different types and each one has its own healing properties. And so, I mean, I live natural farming pretty, I'm covered in microbes. I haven't showered in like 10 years. I smell good though, well, I was gonna throw the litter from my pig pen at you guys, but we're inside, that's not fair. It'll be too clean in here. But no, so right here, this is from a pig. Yeah, doesn't taste like bacon, even though it came from bacon. But it's good. It's actually super dehydrated, so. But I love microbes. And so do you see this quote? Does it look kind of official? Because I made that quote up. I'm Rex O'Culture. It's just the king of hidden something. I don't know. But this here, I believe this to be the truth. That because microbes are small, we're bound to forget about them. Like we are in a revival here right now. We're remembering this stuff. Like I said, like why did we use this and spray this on each other? We're in a revival. We're finding out why we did all these things. And it's because a lot of it had to do with these microorganisms. And as we start to rediscover them, health comes back to us. All this stuff comes back to us. But think of us in, generation. You tell all these people and they're like, yeah, but they just stop, they don't add equal parts of sugar and they don't, and they don't. And somehow the quality of these recipes over time just, and it takes a revival like this to remember the microbes, to study, to see them, to bring back this. I mean, they're inside of you. You get 3% of your body weight, Dr. Park was saying, is microbes. 3% of your weight is something we completely forgot about maybe like a decade, 20 years, 30 years ago, you know, like a handful of people knew. And now a room full of people are educated on this of like, these things are in me, I better take care of them and they will take care of me, right? And so we're about to enter into this like golden age of being in harmony of just like, I can eat cheese because I'll drink some lacto after, you know, and my friend grew it, right? So towards the bottom here, I named a bunch of microbes. IMO, LAB, those are acronyms. Kombucha, Schwasaka-san, EM1. These are all microbes we're familiar with. And these are the things that are starting to come to the forefront now with these different names that we're getting to. But we can see them. In order for you to see microbes with your naked eye, there have to be about 1 trillion present. So when you look at your thing and you see mold on half your fruit and you cut it off to eat the other half, there was already 1 trillion there for you to see. They're on the other half too. You just ate them, you just didn't see them. Mycotoxins. Mycotoxins is what makes the world go round. It's what's driving everything. Certain things are putting out antibiotics here, driving this, driving that. And when you eat too many mycotoxins, you die. But you can heal and clean those out of you with natural farming. But that's the rule of it, is to see them with your naked eye has to be more than 1 trillion present. But to get sick, that's not the key. Who's seen food poisoning in a restaurant and been like, I'll have some of that? Nobody, right? No one would order food poisoning on the menu. They'd be like, nah. And if you could smell it when you're eating it, you'd be like, nah, right? You can't see it, so just a very small amount of bad guys getting out of balance can really mess you up. Small amount. And that's why I have this. Because this enables me to see one single microbe. So if one bad guy is in there and I have enough patience, I could find him. This enables me to see 400 times into the soil. Like, and now I can see these microbes. They're big, they blow up, they're nice. This cost me about $400, actually about $700, because it has a nice camera on it. And this is a really nice one. It's essential if you're going to do any experimentation in natural farming. You want to know you did it right. You want to know you got to have one of these. And I can quickly and easily check. I made a batch of IMO. Should I put it out in my field? I can quickly put it under this to see how many good guys to how many bad guys, what ratios I'm at. This little simple tool here can save our lives. And I don't know how, for how many hundreds of years, this isn't that advanced technology that we kind of missed all this, that the soil's alive and like living. But this gives you the ability to look at it live. If you plate things, you've all seen the chemistry where you made a plate of bacteria on a petri dish. Those only grow anaerobic, non-oxygen that live on that agar. To see soil microbes, you have to, they can only culture a very small amount of them. To see them, you actually have to take your soil, put it in water, put it under this guy, and you can see them all. They won't grow and multiply. They're dying. They're on their way out. But I can see them at least and count them and know. Without growing false numbers of way pathogens the way plating methods do. Plating is not a good thing for soil microbes evaluation. So if someone in a micro lab offers to plate, just say thank you. I have my own plate and it's full. So I learned this from Elaine Ingham, Rodale Institute, really great stuff, looked up them. But this opened my eyes to natural farming. It gave me the keys I needed to be on my own, to verify, to do the science. I no longer had a black box. I now have a transparent LED lit up box. So let's go. So what am I looking through when I look through this? This is my biology primer. I'm looking for fungus, right? And in context of fungus, if you're not a soils person, you probably thought, oh, fungus is not maybe the most palatable word. I love fungus, though. Mushrooms, yeah, are the fruit of fungus. But we use them in natural farming because they're easy to ID. Nematodes maybe even more so, but fungus for our case here so on the right, that picture, that's through the microscope. And one of those pieces of life on there is a fungus. And it's easy to tell because it's the only one that looks like that. There's only one fungus on there, but it's really easy to see. And it's that tube structure on the right, that chunk of tube. And those tubes, what they do is they run throughout. Those are the hyphae, those are the mycelium, those are the things going. They act as electric water airlines. They move everything to the soil. They plug into the roots. They can virtually extend your roots millions, if not trillions of miles. There is fungus in the plants that's designed to plug into this. This whole network is really, this isn't the native network of how it works. These fungus plug into each other, move things. This whole network happens in the soil. And when they do, when fungus gets into your soil, it then gets aerated and clumpy and bigger things can move in. And so fungus are the grand soil architects of creating the nice loam, and then everything else kind of comes in. And the bacteria and the nematodes are kind of, if you focus on the fungus, they will be dependent variables. To look for fungus in the soil is super easy. I make a slide, take a little chunk of soil, make a slide like this. I'm looking for something in my soil that has a uniform width, just like that thing on the right. It's 3.5 micrometers wide, which I judge by saying that one speck I pointed at was 1 micrometer, and I take those specks and I imagine them lined up across there, and I say, well, about 3.5 of those. So I now can get a scale. And so I know it's 3.5 wide, and it's dark brown in color. So I can say, okay, if I found this in my compost or IMO or my soils, I know I'm doing the right thing. I'm headed on the right path of natural farming. I'm bringing more life, more network, more connection, more richness via fungus. When I look through and I see one chunk, anywhere I look in my slide, anywhere I go to this random spot and I find one chunk, I know I now have equal parts of bacteria to fungus. So I'm gonna use that in a minute. So I want to make sure I got equal, like how much bacteria to fungus do I have? And if they're anywhere I go, I find one, I know I'm in the sweet spot. And that's going to enable me to determine, where they're at, especially in a commercial setting.
So 1 to 5 dilution is 1 part soil, 5 points water?
Absolutely. So this is this graphic that I like to use. I created this a while ago, but this is the main thing of natural farming. This is what I'm trying to do, is that this column here is bacteria, and the one below it is fungus. And so if we start out, and then going horizontally is soil conditions. So closest to me is your worst in your weeds, and furthest away from me is our best forest. Like, imagine mango trees. And so we often start close to me on my side, which says that we got 10 bacteria, 0 fungus. If I go out into the yard out here, I go anywhere, and I take this little microscope, I sample, that's what I'm gonna find. It's gonna be hard for me to find fungus. I'm gonna have to search through, maybe I find one. I'm also gonna look at, it's gonna be clumped in like muddy water. It's not gonna be very clean to look at in this scenario towards me. As I start to change that relationship of bacteria and fungus to each other, I start to move further away from me. And if I go into a thriving forest on the far side, I'm gonna find way more fungus by biomass than bacteria. So on that far side, they got plenty of fungus, not much bacteria. On this side, they got plenty of bacteria, no fungus. So somewhere on the middle of this is where we wanna be for growing our crops. Now the way to move along this scale towards me is to destroy your soil. It's to till, it's to spray something that we heard a talk about. Well, I'm not even going to mention it. All those things reset you, and you come back to me over here this side. Sometimes you got to till, right? You got to do something. You got to do some earthworks. You got to do some things. So you come back. You come this way. You've damaged your soil. You want to grow crops. You take the IMO. You take the liquid green manure that I'm talking about. You water this out, and it starts to push you towards the middle. Especially when you start to get your IMO from a really nice forest. It's going to start to push you that way. When you take those IMOs, you put them in your soil and you feed them right there, they're going to grow, and now you got all that fungus working for you, and you've moved further down that scale. As you move into the middle and you get to where it's equal parts, that's 600 to 600, you should not have to worry about weeds in the traditional sense. The plants that are weeds that grow are typically really fast, bacterial-oriented things. As your soil gets more rich and you go that way, those plants aren't going to want to grow. What's going to want to grow is more like perennial ground cover type stuff. And things that aren't as pesky and weedy and spiky. It's going to be nice, lush, leafy, rich stuff growing. So my whole idea here is this scale here of where I want to be here. And IMOs enables me to move further that way faster than any other method that I've discovered. The classic way of permaculture is to come in and plant all the trees on the far left. You go in, you plant your trees, you plant all these things. But in permaculture, we leave the soil empty, right? We planted all those trees. So you'll find in 3 years, the biology will come in, and in 3 years, your permaculture project takes off and takes root, and you don't got to do anything. You can do that same thing by planting all those permaculture trees on the far side, coming in with the natural farming biology, put that into your soil, and now everything, your top and your bottom, are already on that left side. So within a month or 3 months, you're like what took people 3 years. So what's above relates to what's below, but what I'm saying here is that in natural farming, we can get that below factor, because most regenerative projects that are coming back are fixing the above stuff, what we can see. Natural farming fixes the below stuff, the stuff we can't see. And I think that's where we got to start. Start at the soil, start where it makes sense. So that's why I support this. And let's move over there. Right? Let's get over to where trees want to be. Let's shift our arrow. CGNF Solutions get us there. A little bit about how this works is that basically in your soil, you got bacteria at the bottom. Bacteria, the building blocks. They make up everything. When I really start to look at the microscope and the dirt, there's very little dirt. Almost all of it's life. Stuck and glued to life, life on life on life. I sometimes wonder if the continents are just glued together microbes, because there's not that much. Just like when you burn a tree, there's only a little bit of ash. Like there's not much that, like earth, there's not that much. Like it's mostly microbes glued to each other. So we live on top of that. That's our basis, is bacteria. The fungus are the middle layer, which I think they're the most important, because they're the architects and the engineers that take the bacteria building stuff and they build buildings like this, which now gives us a space in here where we're protected from the sun, microphones, audio. Like the fungus built all this stuff for us. And then your top layer of the protozoa and nematodes are us. We're in here to eat the food, to recycle the nutrients, to get the flow, to get it juiced and rolling. And so when you get all three of these layers in your soil and they're functioning happily and healthily, all your nutrients and everything will be provided by this cycling biological system. And we can benefit the most in this by helping our fungus enable this whole pyramid to happen. Put the good guys in, they happen. I think I got a couple more slides. So yeah, I'm going to talk about bacteria and nematodes, and finish up our little primer on biology, which I'm starting to fall asleep. Okay. It's going good though, right? Okay, cool. Cool. Yeah. So, because I absolutely love this stuff, so I can talk about it forever, and and that's the thing that draws me to it is natural farmers, man. The heart, the love, the truth comes out, and then the science backs us up. Sometimes you just like love, and people are like, "Where's the science?" But this actually like backs you up. You're like, "Yeah, it's right there, microbes." And the bacteria, make us or break us. It's everything. Like I was saying, pathogens, microbes. They are your NPK. They're your bags of fertilizer, are your bacteria. They're living bags of fertilizer, and you want them to die at the right time and in the right place so that they're deposited right where your plant needed them. This happens naturally. Plants take sunlight, convert it into sugars, and then pump the sugars, like some plants, like 80% of their sugar gets pumped into the soil. So imagine you're eating food and 80% of it you're putting into your soil, you're not eating yourself. That's what the plant is doing. Why would it do that? Because the biology, the bacteria is exchanging those sugars for things the plant can't make, like phosphorus and potassium and these things. And the bacteria are full of those and they're exchanging. They're like, oh, thanks for the sugar and I'm gonna die right here. And now you got phosphorus there. Because they die quick. They go through a generation every 30 minutes. So, half of your bacteria have already died since I started this talk. You've already now have a new set. Just pretty awesome. Because you got all that fertilizer, and that's why you're still alive and pumping and all those nutrients. Had you got it all at once, you'd have been like, whoa, but then you slow die off is where it's at. No, don't generalize too much on my statements here. So basically, they glue to each other. This glue turns out to be super important. It's called glomalin. And the more you read Acres USA, the more you realize, man, this is a cool magazine. You should read Acres. Because they're going to talk about glomalin, which is this glue that turns out to be fundamental to stopping erosion and all these things. It's what makes the soil is this glue. And it's from the bacteria, and you can't get it without them. So just to sum that up, the plants grow the bacteria with sugars so that they provide NPK bags right where they need them in their roots. The root puts the sugar out, bacteria is right there, it's right where it needs it. So this little system, that's primarily what, as a natural farmer, how I'm gonna talk about biology, or bacteria. Whoa, I got closer. You'll hear a ton about nematodes from Kun Hui. This is her tool for soil, like getting a metric and measuring, did I do good, did I do bad, is nematodes. 4 out of 5 multicellular animals are nematodes. So think of how many animals and things you've seen that have many cells, and then multiply that number by 5 to get how many nematodes there are. Or 4. I don't know, however that math works, sorry. I should be more precise. But basically, if you went out to space and you got rid of the dirt, you'd still be able to see the continents because of the nematodes. They're that prolific in the soil. And when you talk to a farmer, what do you hear about nematodes? Gotta kill them. Kill them all. Let's use this new chemical. Let's not even read the label. We got nematodes. Yeah, no, people want to nuke them, right? Nuke them, nuke the nematodes. But they are 4 out of 5 multicellular animals. So go around and every animal you see, try kill 4 times as much. And so when you think you're killing the nematodes, you're not. You're just upsetting them. And they play a very vital role. There's 4 types of them. There's bacterial feeding, there's fungal feeding, there's root feeding, and there's nematode eating. So those 4 types, typically we're only worried about the root feeders in farming. Root feeders. But they come because we create the conditions for them to arrive. They're so happy. They're like, thanks for just planting sweet potatoes in this whole monocrop. That's what I wanted. And so they thrive, right? so intercropping other ways to mitigate nematodes. But in our case, why we're concerned with them is, remember I talked about the bacteria coming around the roots. Now this nematode swims in, and the nematode's like a bear that's kind of messy. And he just walks in and he swipes a couple people and knocks off their arms, and they're like, oh, and then he eats maybe one, but he doesn't chew their head, and he leaves the legs around. And then he, as he's going out, he drops a bear present, and he cruises. And the nematodes are the bears of the soil, that all this bacteria and these things are right there. And the nematode cruises through and eats them and leaves a bunch of leftovers for the plant to eat. Because if the bacteria is alive, the plant's like, give me the phosphorus, and the bacteria's like, no. But this nematode comes and eats it and just splatters it everywhere, and then the plant gets to suck some of that up. So the nematodes are the cyclers. They're the great recyclers. If you take those out of your field and you nuke them, which you can't just select one, you kill them. Now your nutrients don't cycle. So you got all this stuff out there, and it's just like sitting there, and it's not, it's more bacteria, and then you run into a number of problems. So nematodes also, right when they're in the root zone, cruising around in that rich bacterial area, they're big. They're making airspace that roots are also large. So roots can penetrate and follow the holes that nematodes make. They're tiny little worms. And I found that their population is in balance if your fungus is in balance. I've never seen nematodes be out of balance if the fungus was in balance, except for one time on Molokai where I looked at this pot where he had been taking IMO and burying it in a pot. And when you bury IMO, it becomes anaerobic, and you kill it, and it becomes like it's so rich that now it's this feeding ground for, it's like zombie land or something, I don't know. And what happened was that thing was swimming. There was a tree in it, in this pot. Tree was perfectly fine, perfectly fine. You look at that, you think, oh wow, great seedling. I put it under the microscope. It was swimming with fungal feeding microbes, nematodes. I'd never seen more nematodes in a sample. This thing had like thousands of nematodes, and they were all fungal feeding because I looked at their mouth. They were all eating fungus. So he had buried the IMO. The IMO was tons of fungus eggs. They had gone, turned bad, and now this was a feeding ground for all these nematodes. So you look at the plant's doing fine because the only nematode that's going to affect your plant is going to be a root feeder. So you look at it, you think, oh, it's fine. You would never know that if you took that pot and you put it into your ground, you've now inoculated your whole area with fungal feeding nematodes. So you've unleashed, all your nice fungus. You got your garden bed, you put this pot in, now you got all these fungal feeding nematodes that take off and go nuts. And so by mishandling the IMO, you can actually grow bad guys, in our sense. But it wasn't affecting the plant, right? And so without the microscope, you look at the plant, you think it's okay. But this is what this tool enables you to do, to see these larger indicators of that was not a healthy situation. And I know that it was because the IMO was in there, but this would give you, like a way to diagnose those types of issues. So I also love nematodes, but not as much. So what I wanted to do, I hope you enjoyed this here. I wanted to kind of show a little bit here of, I've been doing this for 8 years. I don't know. These are pictures taken in 2008 or 9. I don't remember which year, but in October. And that's in Korea. I took my beard off that week. Sold it to like that, like Locks of Love or whatever. No. But what they're doing in Korea is they're growing just the most amazing produce. Like, look at that apple. It's picture perfect, not a blemish on it. So sweet, so thin the skin, just tastes off the hook. They're able to market that to Seoul. We have a market of Honolulu or Maui even. But they're doing amazing things. That's the group that I went with in the upper left. You can see Mike DuPont, Kim Chang, Tanya Paulton. Who else? There's a bunch of superstars in there. Mike, Liz, yeah. My dad, yeah, he's cool too. And Dr. Park, yeah, exactly. But we cruised around Korea. We saw all these operations. You know, they spoke Korean, we spoke English. We had a translator. We tried to learn what they were doing, but it's been 8 years since we've done it. I feel like at this point, I've reverse engineered it enough to like have that quality standard we're all looking for. You know, like if I taste your input and I know whether it's good or not, you know, and then I can bust out my microscope if I really want to double check on. But we toured orchards. We saw extremely successful operations here. The bottom left is a persimmon orchard there. That guy did nothing. He put a little bit of calcium out right when his fruits were going off. Other than that, he didn't, you know, and he was doing well. So from that Korea, I kind of proved it out here a little bit. This was downtown Hilo. That was that triangle that I talked about that was nuked with toxins. And we grew a huge kalo feast there. This was 2011, 2010, maybe 2010, 2011, right in there. And we grew all this taro downtown, biochar, IMO, coconut, little bit of dolomite, and solid. On the right, more downtown Hilo. When I started the project, it just looked like all those spots were moss and just like, you know, I was like, man, come on. So I got inspired because in elementary school, we had revitalized Liliuokalani Park. And I moved back here and I learned natural farming. And I was like, well, so I just did this project. Now it's part of Let's Grow Hilo. It's still down there, all natural farming right on our streets. And we grow taro. And I've been doing natural farming since I had the sprayer in my car. It's super easy. Now I just drive by. Like before I had to, you know, like, but just to show people natural farming, this is how, you know, and this was part of my learning curve. Like I just went in and did it, you know, and done a lot of things good and a lot of things, you know, always improving. But now I teach school, work with elementary school kids from kindergarten till 8th grade. And it's been so fun to get them into the garden and give them something that they can get, you know, their hands in and teach them what dirt is versus soil and what's dirty and what do these things mean and where does our food come from. And so we'll have a lot of natural farmers pretty soon, more coming up. And I love it. That's us turning IMO. Up top is a picture of IMO that we looked at. There's one of my students using this exact microscope here. And, you know, teaching them the depth of the soil and how important that is. That was a good metaphor. So, and just, you know, in Korea, we saw some commercial things. They had a really high-end market. We're trying to get it together. Chris sent me this picture a couple of years ago. This is him, you know, this is his sprayer setup going through a MacNut orchard to spray natural farming inputs. They had put IMO down on the ground here before doing this. I went to this same row recently, and the grass is gone. They don't mow that section anymore because you got to mow MacNut orchards to pick up the nuts, right? They don't mow that section anymore, and they don't need to. The IMOs have gotten rid of the grass because it's so fungal in that environment that now they just pick up the nuts. So where you see them driving on grass, it's now not in that row. And he's done a few hacks. Like you see the thing up on the right, that's his fermented plant juice with a 5-gallon tote, you know, water boy thing. To make enough on a scale large enough, you got to get, you know, of scale and size. I love to do half-gallon jars, but I often make 5-gallon buckets of things to have enough. But one 5-gallon bucket, you know, makes 500 gallons. So I love or more than that, times that by 5, 2,500 gallons. You know, so the multiplication factor of making these things makes it okay on a large farm. Your startup, because you have to make all your inputs, can be a little rough. That's why I have fermented plant juice available in large quantities. So if you're a farmer and want to get like gallons, let me know. And that's, yeah, so that's his setup. It works on a large scale. Love to get more of that. And then, so what I wanted to just finish up, I think this might be my second to last slide, was this is Master Cho, for those of you who haven't seen him. He kind of looks like the image. That's the official Korean, you're part of his club farming there. Our logo is very similar to that with Cho. What he's doing there, he's putting his hands like this. That's the Korean way of saying I love you. So, yeah, all together now. Ew. Now, I will take a picture of that before I go, because that way I could send it to him. He'd probably be stoked. But what I love about natural farming is that, it can do commercial, and we can have commercial dreams and go that way, but I think growing your own food, being local, more in a community. So I put in that lower picture down there, that's a classic picture. That's Ginger John from back in the day with Dr. Park, when that was like one of the first IMO piles he turned. And what I love about natural farming is it brings us together. More than anything, like look, there's 8 people turning that pile. You just being part of it, it's all edible. It's just, I love the inspiration I've gotten from Master Cho. And what I'm doing here is kind of like to pay him back, or I don't know how you say that, but like wanting to he's given this great stuff. So for me to be here to talk to you guys is like, that's cool, so in his, So I get one last slide here. No, let's just skip this one, go to the next one. So this is my last slide here. And I just wanted to show you where I'm at right now of this. This is my school garden. I'm gonna be one of the garden tours on Saturday, and we're gonna go to this school garden. And so, I turn this place from a yard into like a food forest. And I love being in it. I love growing things. I love observing and being part of nature and cooperating with it. And thank you. May the beneficial microbes be with you.
So I'm actually not a soil biologist. I do a lot of work with vegetable quality, crop quality. We work with a whole group of folks to address issues related to specifically organic ag, but more broadly sustainable as well. Whole bunch of groups working together. We get a lot of support from Western SARE. Stacy's here. I saw Stacy earlier. Representative from the SARE Sustainable Ag Research and Extension, Department of Ag, College of Tropical Ag, whole bunch of folks working together. When we talk about soil fertility, we're really talking about soil health, as was mentioned previously. Cover crops are incredibly important. We do a lot of work with covers. I'll talk briefly about that. Not just for near-term and more importantly long-term benefits, but cover crops really enhance the ecological function of the whole system with beneficial insect habitat. The rhizosphere is just leaking all kinds of exudates and stimulates soil biology. Compost is a effective way to really add very quickly some of the more stable organic matter components. And we've done a lot of work with compost, talked briefly about that. And then we always work with high nutrient fertilizers as well because they need to be included. I have 10 minutes, right? Yeah. Okay, make it quick. This is kind of what our lab does. Historically, we do a lot of quality analysis, looking at the links between how you farm and how that impacts flavor, nutrient density, things like that. And that Jana's big on that too, and she'll talk about that. But the needs, when we look to see what people are interested in is, soil quality. We're doing a lot of work with coal, and sugarcane was brought up earlier, and it was wonderful to see the sugarcane juice. A lot of interest in sugarcane varieties as a horticultural crop, juice, and things like that, and so we're doing that kind of work. But with regard to soil fertility and health, there's big need for that, especially with regard to local fertilizers, and that's why natural farming has created so much interest, and it's important. The light, is there a way to dim these lights a little bit, or it's not critical, I guess, but bottom line here, there's a couple of soils. So we work in a wide range of soils, and as you know, Hawaii soils are very distinct. Can be very complex, but we have extremes of very weathered, fairly infertile soils like this Altasol on the left, and the Malasa on the right, naturally much more fertile. Typically, with pH being important, so these are some of the chemical indicators of health or quality indicators. Typically, if you look at something like aluminum, where aluminum toxicity can be an issue, with that lower pH on that Altasol, it's more plant soluble. This is all plant available in parts per million for the phosphorus, potassium, calcium, magnesium, aluminum. So big difference in the soil. So we work with a lot of different soils to see how these amendments might respond differently in different systems. And so we do a lot of work with cover crops. And this is you can see the little purple lab in there with the sun hemp. And this is Waimanalo, that's Pu'okona above it. We have 4 acres of certified organic land out there. We work statewide, and so some of you may have attended the cover crop field day in the wintertime of Waimea a year or so ago. And so there's the sun hemp is kind of the superstar of the low elevation legumes, and the fava beans or the bell beans for higher elevation do pretty well, especially in the wintertime. So there's a number of cover crops that do better at higher elevation, like Waimea, Pakula, especially when temperatures drop in the wintertime. So, nitrogen fixation is important. People get really excited about it. And cover crops are so much more. Grasses are very important, even though they don't necessarily add much nitrogen to the system. But a lot of folks look at rhizobia and the importance of cover cropping. So these are some of the crops and the nodules we deal with. We've done a lot of different work with different cover crops. One of the points, and I don't know if you can see that top sentence, but some of our tropical legumes, most of our tropical legumes nodulate fairly easily with our native bacteria. So things like sun hemp, perennial peanut, which is being shown here, cowpea, will nodulate naturally. But you saw those chemical profiles, the nutrient holding capacity, the characteristics of the soil that might make it very poor to hold nutrients also creates a poor environment for microbes. So you typically don't have as vibrant microbial population in these weathered, depleted soils. And so even though if you were to add inoculum if you add biology to legumes and put them in a rich soil, you get no real difference in growth, performance, or nodule size, nodule number. But when you do it in these more poor weathered soils that have been depleted, even though the bacteria are there, you get a big difference in the nodule size. It's not direct proof of fixation, but certainly plant growth and establishment. And then the color of the nodule, which I showed earlier, can indicate whether or not it's fixing. So we do recommend adding some biology if you're starting with a poorly weathered soil. But if you build with organic materials, that's less of an issue, and that's the primary way to build the soil. So we do a lot of work with compost. And I split compost up in different ways, and we talk about some of these larger commercial operations that can produce a very good quality product. And then you have these smaller operations, usually on-farm operations, that produce a product that I call handcrafted artisan compost. They spend a lot of time and energy trying to make this real high-end product that's fabulous. Huge microbial, we have huge differences in microbial activity in these different composts, tremendous differences. And the challenge, though, it takes a lot of time and energy to do that, even if you're making your own. And so you would use those more strategically. So we work with a lot of growers with using the commercial green waste base type compost, maybe adding a little bit of the tankage material that comes out of island commodities, that fish, meat, and bone material, to jack up the nitrogen a little bit so you don't get immobilization and you increase a little bit more biological activity. But the vermicompost and the more handcrafted composts are used often either as compost extracts or as seedling media. And so you can very strategically apply that material, and you can see big differences. And the quality is expressed, we call this bioassay. This is a difference in 100% compost that's got a CN ratio that's higher than it should be. It's a little too woody. So addressing it with a little bit of nitrogen, again, from an organic source can adjust that, or just making sure that it's matured before using. And then you got something that's well matured, a nice vermicompost that, these eggplants were planted at the same time in. So it's important to pay attention to quality of the compost. Side by side, they were planted at the same time. Yeah. Yes, ma'am. Yeah, I haven't done much natural farming, so I'm just talking about some of the stuff that we've done. And we work with Dr. Wang, who'll be talking later. And so I haven't done much natural farming, actually. So I was asked just to come and talk a little bit about some of the other things that we've done. So sorry about that. So we've done quite a bit with extracts, compost tea, a lot of stuff published in referee journals, and then we try to synthesize it into something a little more accessible to practitioners. And so we have this available online. If you just Google this, it'll pop up. Compost quality is all in the front. Biological activity is a big part of the book, and there's quite a bit of data in there. So that's...
Said there was a whole thing about not using molasses in compost teas.
Yeah, so... Sure. So we actually don't necessarily advocate foods in general in the compost tea. Specifically, the molasses, what people are concerned about is simple sugars will rapidly increase certain bacteria at the expense of other, and so you'll shift the biological diversity. You'll minimize it, reduce it, and so most folks now who do use foods, microbial enhancers, recommend blends where simple sugars are eliminated or a very small portion. And so humic acids are very common, like that material you have, kelp extracts and things like that. And the idea is to stimulate biology. What we found, though, is that really the most important component is the biological activity that's occurred in the compost prior to application. If you've got that, that's really all you need. You can see some differences when you use other material, but it's unpredictable. And so we don't have good recommendations for foods. And if you're using foods, and I'm turning this into compost tea talk, so I'll keep moving, but if you're using foods, you really have to aerate, and you have to really pay attention to that. If you're not using microbial enhancers, you can get away with not aerating. It takes a little bit longer, and the instructions are all in here. So it's a little bit complex. So there's actually quite a lot of opportunity for science in this area. And one of the reasons I was not nearly as brave as Kunwi, Dr. Wang, to get involved with Korean natural farming, because it is a whole system and it is very complex and everything is. And so for scientists who are used to breaking things down, more challenging, So, question? So the compost tea, and I'm wrapping up here, I'm almost done, really worked great. And there's three mechanisms that we figured is causing this plant growth promotion. There are quite a bit of micronutrients, especially that are in the tea that may be enhancing, although the enhanced growth that we saw wasn't explained totally by that. We did see quite a bit of gibberellic acid number 4 that was in our compost that were the most stimulating, and there was a strong correlation between, and so it's basically a microbial byproduct that acts as a plant growth stimulant, and what it does is it stimulates root growth. And so in addition to some additional micronutrients, we suspect that the plant was able to intercept what nutrients are already there, because roots aren't 100% efficient in intercepting what's available, right? And then finally, and I'll show a slide here on enhanced biological activity, we don't break down it's hard work, and there's a lot we don't know about soil biology. But we do basic measures like respiration, which NRCS does quite a bit of. And we use a number of other tests to look at total biological activity just to see how things have been stimulated. And when we looked at and I'll walk you through this slide, and this will be my last slide essentially. When we looked at how much biological activity was occurring, we see huge jumps, whether we're just putting compost material, other organic materials, if we're doing compost extracts, all of those things really jump the soil biological activity. And one of the things that we assume is happening, that we see at least in the plant response, because to me, plant is ultimately the biggest integrated measure of soil quality, right? When we're talking from an agricultural perspective, soil quality is really basically the ecological function of the soil to support plant growth. So when we look at the plant, we see big responses with the additional organic matter. And when you look at the soil, so if you look at this graph, this is not yield, this is CO2 emission from the soil, which is a measure of total biological activity. When we look at the perennial peanut, we did under the perennial peanut and under weed mat instead of perennial peanut and bare soil, and the perennial peanut was like a forest floor. It was very active, equivalent to levels that they measure on forest floors. The black mulch was way down. We didn't have weeds, but we didn't have much else going on under there too. So the idea of rhizospheres being very important. Sources of carbohydrates for biology is something that should be hammered home over and over again. So, one point is if you just look at the plants that were fertilized primarily for nutrition with compost, and then compost tea was added on top of that, you can see the biology much higher than the synthetically fertilized soils. So regardless of what we did after we put the organic amendment or the synthetic amendment, the organic soils were higher in total biological activity. And then when we looked at the different types of compost tea, if you look at that far, I might as well use this since I have it. If you look here, this is the control, which is just water added in the same quantity that we added the extract, the compost extract. And so this is the baseline soil biological activity. When we added a complete soluble fertilizer solution, we actually got numerically lower, statistically lower values when we added a synthetic fertilizer source. And then these are the compost teas that were added here. And this is, again, the soil biological activity relative to the other treatments. And you see essentially the same pattern here, just lower under the synthetic fertilizer. So again, our group works with a lot of soil biologists, Kunhui especially, but we focus on kind of crop quality and productivity. So thanks for your patience, and turn it over to.
And next up is James Rushing.
Hi, everybody. James, nice to meet you. I'm going to play devil's advocate. I'm going to be the stick in the mud. I'm going to be that guy today. And since I'm supported by several scientists, I'm going to talk about the science behind natural farming, a little bit of some truths, maybe some myths, and what we know as scientists and biologists about natural farming. Just real quick about myself. I have a bachelor's of science at tropical plants and soil sciences at UH Manoa, and a master's degree for tropical conservation biology, environmental science at UH Hilo. I'm also the interim professor for sustainable agriculture at UH Hilo. Also a researcher and a hardcore natural farming advocate, as much as I possibly can be. So I've been with this group for about 5 years, and my knowledge of sustainable agriculture has evolved with this. And I'll have you guys know I do teach a lot of these concepts in the sustainable agriculture courses that I teach at the university. So you guys are actually having students being taught natural farming practices. So I like to incorporate them as much as I can. It's hard to see that in the title on the top. But I did just recently finish a thesis, a 3.5-year study on IMO4 as a soil inoculant. And I actually will be presenting that information at the natural farming meeting on Tuesday next week. So if anybody wants to come out and check that out, it's definitely useful information. And I have several individuals that were on my committee are here today, Dr. Wang and Theodore Radovich. So if you're interested in a detailed look at IMO4 from a scientific perspective, I invite you to come out and take a look at that. But I just want to briefly talk about, as a scientist, what we know as scientists, what we know are the benefits of natural farming. Certainly, as Ted has just explained, and as a lot of us know, that increased biodiversity in the soil is definitely beneficial as compared to not having any sort of biological entities in the soil, right? Soil organic matter and biodiversity certainly creates a balanced system, and this is important in biology. Creating a system where not one microorganism is stronger than another, and you have plenty of nutrient resources and organic material to break down. Competition is reduced, and you have more of a system that is similar to a typical natural forest system. So, and then utilizing adapted microorganisms, there is some science behind that. Some studies have showed that microorganisms from the immediate environment will behave differently or better, even in conventional or organic environments. So really just utilizing indigenous microorganisms, definitely a benefit to sustainable agriculture. Environmental, natural farming will certainly reduce fuel consumption, fossil fuel consumption, whether it be in the delivery of materials, the shipping, or production. So definitely increase sustainability on that end. Reduce pollution, we're talking about nutrient pollution specifically, so we're talking about as compared to conventional and some organic fertilizers, natural farming amendments having a much lower concentration of certain nutrients, and utilizing the enzymatic activity of microorganisms to break down organic material and have these nutrients trickle in at a very, very slow pace and small concentrations, and that's more what plants are used to in nature, right? And then also reusing waste and byproducts. Yeah, waste management is a major part of natural farming that I'm involved in. I love to try to make new fertilizers using the methods that are done in natural farming. And then taking byproducts, things that are considered waste, and then utilizing them back into the field certainly is an environmental benefit. And then, of course, improved soil dynamics. Just the fact of adding soil organic matter is going to increase your soil dynamics, aggregation, pH is going to settle out, you're going to have a little bit better water retention. So these are just definitely some benefits that you're going to find in Korean natural farming, or natural farming in general. These are some possible negative effects that that could be incorporated into natural farming. Yeah, I'm a stick in the mud. I got to play devil's advocate. There are some certain things out there that I want you to consider from a scientific perspective when you're looking at natural farming. There are several pathogens that will survive fermentation and thermophilic processes. Know that that is possible. We do not know if natural farming techniques would get rid of those. We don't have any science. We don't have any science out there that actually shows that. And again, another call to arms to anybody doing research that this is something that we definitely want to look into, is the transmission of pathogens with natural farming. Also, pathogens and pests and material transfer. As a consultant and natural farming advocate, I tell these people to utilize these methods, and then I have issues with the people that I work with actually having disease arrive on the farm only just after natural farming amendments were applied. So there's certainly something to be said there. I have several cases where this is an issue, and I call again anybody who's interested in this, maybe contacting the university saying I have a plot of land, or maybe we could figure out a way to do a study and find funding. So if that's something you're concerned about, as well as pests. Fire ants, big deal with a lot of natural farmers transferring IMOs and transferring plant materials. So definitely a negative aspect to the whole scheme, right? Mineralogical problems that can arise. Well, by adding high nitrogen, soluble sugar concoctions, you're certainly going to disturb the carbon to nitrogen ratio that Ted had just brought up. And that is certainly going to affect the mineralization within your soil. So without an understanding of how much nitrogen or carbon you're adding into your environment with your amendments can be very detrimental, at least to the use of the fertilizers themselves. So understanding how much carbon, how much nitrogen is definitely a big deal. Also, there's a lot of soil scientists that are talking about natural farming being an issue, having an issue with soil mining, and this is where microorganisms break down mineral sources and organic matter sources, and then those minerals are not actually replaced back into the environment because some protocols in natural farming might dictate you don't add fertilizers or something like that. So it's really just a matter of having a standardized protocol, and I think with that standardized protocol, fertilization is incorporated into it, you won't have such a big problem. And then also the rapid mineralization. If you are to put out a soil inoculant and it succeeds in actually surviving that inoculation process, add organic matter out there, those microorganisms are going to start breaking that material down very, very quickly. And then if it's breaking down a large amount of it very rapidly, a lot of that material gets leached away and lost. So there needs to be studies on the mineralization of the organic matter, and if inoculation speeds up, slows down, could be detrimental, or that kind of thing. I'm just again calling for research in these fields. These are myths about natural farming that a couple folks have taken classes with me, have seen this before, and it's really just myths from a scientific perspective. Number one, we know that it works. We don't have any studies out there that generally show that it works in multiple locations using the same protocols and all that stuff. So there's just a whole bunch of information that we need still to find out, even if the system works, where it works, or in what environments. If it works, we know why it works. No, we don't really know, because microbiologists are a pioneering type of field. We know about 1% of the microorganisms available in the soil, and which is a great improvement from 30 years ago being 0.001. We did a great job once PCR and genetics started getting involved, but we just have absolutely no idea what's going on in there from a scientific perspective, to be honest. Yeah, we have these theories and we prove facts here and there, but it's just few and far between. It works all the time. I definitely have proven in certain situations that it doesn't work on one guy's plot and 2 miles down the road, and it works wonderfully. So there's no studies out there that it's successful in multiple locations. There are top-tier, peer-reviewed scientific articles that show significant data. Not one. Not one. There are reports out there, but they are not top-tier. Okay, we're talking like the scholarly level journals. Now, the asterisk on there because I hope to have one up here really soon based upon my research project. And that's pretty up to date. I mean, I think there might be 1 or 2 coming out pretty soon with thesis experiments that came out of New England, and a couple other individuals things are coming out. But right now, that's the way it exists. Only specific materials need to be used. Depends on what school you come from. Are you part of the school that you have to use specific elements and you have to purchase them and mill run or whatever versus something else? Well, I've done preliminary experiments and show that there are materials on this island that are available that actually work better than some of the prescribed carbohydrate sources. Like breadfruit flour works really well, and it's a sustainable source and it's local. Again. It's still considered natural farming if the materials come off a boat. At that point, you're organic farming, as far as I'm concerned, and most scientists are concerned, at least for the natural farmers. If you're buying sugar that came off a boat, if you're buying all these things, it really, I would suggest, is trying to steer your system to what is available to you and what you can utilize. The protocols that are written in a lot of these books, folks will tell you have to stick to them, and some folks will tell you try something that works for you. So that's my recommendation. IMO4 is the answer for everything? Definitely not. Seems to be, that's a regular suggestion in a lot of the classes I have. Some people have found success with it, for sure. I don't need fertilizers in my natural farming system. Again, I'm talking about that soil mining, not replacing those macronutrients, but more importantly, the micronutrients. The boron, chlorine, all these other elements that are really stripped away by microorganism decomposition. Unless you're replacing them back with organic matter or any other amendment, you're not going to be as successful. And then natural farming is the answer to all my problems. No, find out what works for you. Figure out your system. What can you incorporate from here over there? Maybe at some point along the way you can get to the point where you're 100% natural farming and you're doing all that, but don't try to come in and be successful right off the bat. It seems that most of the successful people kind of trickle in this, bring in that part, figure out that this doesn't work for them, and they replace it with this method. Well, so consider this. This is my call to arms. Really just be scientific in your understanding of natural farming. Don't fall for the proof is in the pudding. I did this experiment. I had wonderful growth. Well, that's mainly because many factors can contribute to plant production and plant health and disease suppression. That being said, I don't mean to be a negative Nancy. We have a lot of potential to show that things are working, things are beneficial, that we can spread this information out to the world and have people access good, legitimate data. But what we need is science and researchers and CTAR and all these organizations and farmers like yourself going to these organizations and saying, I have an interest in the result of this study. I have land. Let's see if we can put something together, finding funding and seeing if we can put together a publication which will benefit everybody in the future and allow those individuals to make the right decisions for them. Okay? Question?
You said that the barrels were depleted. Where was this done? Was it done on lava or was it done on?
Hakalau. 3 farms in Hakalau.
So I think it would be different for lava, yeah.
Oh, I would say certainly when you're talking about soil differences, definitely.
Endless minerals in our always way in our
Right, that's why I call for this type of experiments, all those experiments being done multiple locations all over the island, on different islands, in the mainland, in Europe, and Africa. We need to spread out this research and bring it back home.
What kind of pathogens were present in the ferments?
Oh, I haven't found any, but there are pathogens that have been known to exist in past fermentation and thermophilic composting. I don't know any off the top of my head, but I can email you a list. Let's see if I can. Microscope identification of microorganisms is very difficult. Oh, certainly. But I'm done, so yeah, that was it. Yeah. And we'll have Josiah next. Okay. You're as loud as me. We're good. I'm going to turn it off.
I'll just talk loud. Y'all can hear me, right? Yeah. Okay. Yeah. You got it in there? Okay. So, I'm going to go through this quick, and then I'm going to run. I got to go pick up my kids. So, if you got a couple of questions, we'll just make them super quick, and I'll be out of here. But I've got to run. I've got to just do this. So, okay, cool. So Pacific Biochar. I just kind of started this biochar pathway a long time ago. First company I started truly dedicated to biochar was Hawaii Biochar. I'm now doing work in California and Oregon and Washington, and also in Southeast Asia and Australia now. So it's grown to become Pacific Biochar. So if you want to find out more information, because I left too quick, you can go to the Pacific Biochar website or send me a link to that or something like that. So what is biochar? This is really important, and this has been evolving. And I've been working on this, and so I have like this 3-paragraph definition, and I just boiled it down to the most essential, which is biochar is a term. It's a term, not a material. Biochar is a term. And the term refers to biomass charcoal when used or found in soil. That's it. So if you went to the store and got a bag of charcoal, and you went and used it in your barbecue, that's charcoal. And if you took that bag of charcoal and went and crushed it up and used it in your soil, at some point along that line, it became biochar, just because it's a term, and that's how we use that term. So you'll hear me relating to that, especially like right here. So this isn't Iowa isn't the first place people usually think of when the term biochar comes up. But I found this really interesting, that Iowa's famously fertile soils are now estimated that, that 30 to 50% of the organic matter in that area is pyrogenic organic material. Biochar, for lack of better words. So fires race through the rangeland and create ash and charcoal, and that adds up over time. And one of the scientists who did the work on this, Bruno Glaser, some of the original work on this, I asked him, oh, naturally produced from grassland fire. He said, well, humans lived here for 10,000 years, so I'm not sure if we can call them naturally produced. And one of the reasons this has been not really in the front and center for so long is because typically the way you measure carbon or organic material in soil does not differentiate between pyrogenically derived, fire-derived carbon and wood chip that decays. Because it often involves a burn or other tests that don't really pull that out. You have to run through a magnetic, near resonance magnetic, electromagnetic microscopy, something I should remember the name of, but I don't. All right, so anyways, this would be kind of where the biochar part fits in. And so this is your standard view of what's in our soil, and we just had to come up with the word biochar because it became so obvious that wow, there's a bunch of burnt stuff in our soil too. It doesn't decay very fast. It does decay eventually, but it decays so gosh darn slow that only a little bit is needed to accumulate in soil, and so it does. And so one way to call it is pyrogenic organic matter, or we just call it biochar. This is in the Amazon. This is a terra preta soils. This is often what a lot of people think of if they've heard of biochar when they hear that, because these soils are just such a very, very stark, very stark and clear picture of the value of charcoal in soil. Because typically in a tropical environment with 200 inches of rain, this is what your soil profile is going to look like. Organic matter is being created and it's being decomposed and washed away, and nutrients are washing away. And the heavy rain just kind of pushes everything away. These soils, this is actually just a few hundred feet away. These soils were made by man. These soils were made by the people that lived there. And they have lots and lots of charcoal in them. And the charcoal helped allow the minerals and the organic matter to stick. All right? So that's not just black because they put a bunch of charcoal in it. The amount of organic matter that's not burnt is much, much higher in this soil than it is in this soil. So it actually gave something for everything else to stick to. And this was so mind-blowing that humans created these incredibly fertile soils that, again, it sparked this whole thing about biochar. And just to kind of show, this is, they scraped the forest off and planted some corn and planted some corn. That's fertility that lasted for 500 years after the culture died, or whatever happened. Germs and disease and stuff like that tend to kill off most of the Amazonian tribes. So that soil has been basically leached for 500 years, and that fertility remained. So it was kind of stunning, and so that kind of spawned this whole idea of biochar. And I'm taking a long time. Forgive me here. So that's what it looks like up close. That's a spoon. That's what I view as biochar. That's a wonderful material that I moved on the mainland. Here's that same stuff inoculated. It's covered in mostly actinomycetes and other things. I send it through a biological process to make it more like the biochar is like the surface of the moon when it's freshly created. So I culture it a little bit so that it's more readily accepted by soil and plants. We get better results that way. Here's biochar very, 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 very up close. All right, so you can see this picture does a good job of showing you that the plant, this is bamboo. The plant has vascular tissue. It carries food and water throughout its body from the soil up through the leaves. Right? It's carrying things all through its body. It has a structure. When it's burnt, like in that first picture where you showed that it was glowing, right? When it has gone through being a piece of wood to a glowing ember and then cooled without becoming ash, that structure is essentially frozen in time. All the carbon connections that were cellulose and hemicellulose and lignins those bonds, the larger bonds that created the structural elements of that plant's body, get frozen in time. You can find pieces of biochar that are hundreds and hundreds of years old, and you can be able to identify the species of wood or the species of plant that it was created from. And they do this in archaeological digs, in fire pits and stuff like that. That's how they find out information about really old tribes and stuff. So that is really important, and all that gunky stuff around that's bacteria. This is a composting study with bacillus, and they found that biochar dramatically increased the rate of biological activity. So it gives you a size reference. So that's the bacillus bacteria in the biochar there, and then here's a mycorrhizal. Here's the spore. This is a glomus spore, and then here's all the hyphae. You can see the size is just beautiful. It's just perfect. All the fungal hyphae, that's the fuzzy stuff that you would see, like the cottony or kind of thread-looking stuff. It's just plugging right into the biochar. I feel like this picture is important. So then here's stepping back a little bit more. This is in a compost pile in my yard. This is a piece of charcoal I pulled out of the ground. I had to literally pull this out. This was a piece of charcoal that was in a composting experiment I was doing, so it was loaded with nutrients. And then I went a year or two later and pulled it out from underneath the long gone tree. And you can see here that it's covered in roots. And there's roots going in and out and in and out. So you can actually see a root coming out of the biochar. Again, showing that this is from living tissue that has tubes and tunnels. So with biochar, it's not like a chunk of gravel where the surface area is determined by the exterior surface. It has an interior surface, an entire, for something this large. I mean, that's like a planet. If you were a bacteria, the size of that, you could probably have 1 billion bacteria living on that thing, probably more even. So again, showing how this material might be very interesting when thinking about soil biology. So this is a study from the Amazon basin that I think really kind of captures, again, why in Korean natural farming they were suggesting using charcoal, and why in a lot of Korean natural farming recipes and the making of IMO and in plant propagation and soil treatments, they talk about charcoal in this system that's very biologically intensive. This is really big. So here they did a study, bacterial community composition, right? So how much and the composition of. In Brazilian anthrazols, anthrazole is basically a human-made soil. That's referring to the terra preta soils. And the adjacent soils, meaning the soils right next to them, using culturing and molecular identification. So here it is. Here's the community in the anthrazole with a bunch of charcoal, and here's the community without. I think that really just kind of captures it there. That's kind of like healthier. That's the healthier soil. Just looking at the microbial diversity on that and abundance. Well, I guess this isn't abundance. This is diversity. Again, so I said that bag of charcoal. You can go buy a bag of charcoal and then you put it in your soil. All of a sudden, it's biochar. Typically, when you are creating charcoal, you're selling it for its weight and its thermal value, and you'll typically be in this zone. Whereas biochar production, you're trying to get a product that has very high absorption, and you're oftentimes gaining that energy. So you're typically going to be in this zone. It's kind of important that barbecue charcoal can work, but it's not necessarily ideal. So I've probably got, how am I doing on time? All right, I'll make it really quick. The next few slides, I'm going to go through some of the aspects of biochar and some of the research articles that have been published. There's now about 3,500 peer-reviewed published research articles regarding biochar. Not only biochar by name, often if they're using the name charcoal or pyrogenic organic matter, but basically there's about 3,500 research articles. So these are some of my favorites. All right, so here we go, biochar and water. Biochar application increased growth, drought tolerance, and leaf nitrogen, and water use efficiency of quinoa despite larger plant leaf areas. So they were bigger, and even though they were bigger, they still used water better. Instead of being bigger and just sucking, and just running out because they were too big. And then this is a really recent one from Italy. They did a 4 years field trial in a very well-respected vineyard in Italy. And they found as much as 66% increase in the yield without negatively affecting the quality of the grapes. What was really interesting is that over the 4 years, the greatest difference in yield was inversely correlated to weather. Meaning, the worse the weather was, the better, the greater difference in yield. So on the dry year, basically, the biochar test plot was really pronounced above the other. Biochar and nutrient management. Basically, biochar helps, okay, I've got the 2-minute flag here. Biochar helps hold nutrients in the soil. It holds nutrients against leaching and reduces volatilization as well. It's extremely high surface area. In the palm of my hand, a gram of biochar, what could fit in the palm of my hand, if you were to fold that out to be two-dimensional, completely two-dimensional, one plane, it has the surface area of this entire room.
Wow.
If it's a good biochar, it has the surface area of a basketball court. In the gram of your hand, in the palm of your hand, unfold it completely flat, and you cover a basketball court. So extremely high surface area, and a surface that that is adsorptive, meaning that ions of positive and negative charges and minerals and stuff in your soil can bond the surface. And this becomes more pronounced as humic acids and fulvic acids bond with that surface as well. It becomes extensions of that. So what we find is biochar treatments consistently decreased nitrous oxide emissions, which is 300 times more potent than carbon dioxide, consistently decreased nitrous oxide emissions by 14 to 37 to 73% from the alphasol and vertazole. It's two different soils there. And by 23 to 52% from the vertazole. The leaching of ammonia, so this is going down, the leaching of ammonium was reduced by 55 to 93%. So they lost less nitrogen. Really kind of important. This is another one that was just done recently. This one, they mixed the biochar with the fertilizer and found great results. They mixed the biochar with the compost and found great results. Rather than spreading the biochar throughout your entire field to increase your net capture, like basically creating a better filter, they just put it right in the fertilizer and right in the compost, and basically were able to achieve somewhat of a similar thing, which is more economic approach. Locally, I sell a fertilizer that's taking it's a fish meat and bone meal from Oahu, blended with biochar and some other minerals, and that's used over on Kona side, mostly in coffee farms, and those guys love it. For that same reason, we're losing less nitrogen. Here they use biochar in a poultry litter. All right, so using it in a high nitrogen composting situation, and in that they reduced the ammonia concentrations in the emissions were lower by up to 64%. So they reduced ammonia emissions in the poultry litter by 64%. And then the total loss of nitrogen was reduced by 52%, where the biochar was used in the compost, in the high nitrogen poultry litter compost. Okay, biochar with microbes and fungi. And I've kind of gone over that a bit already. Lots of great results and some scientific studies. Biochar and soil contaminants. Specifically for Hawaii, this is very important. We have a toxic legacy left over from decades of not knowing and putting lots of bad chemicals in the soil. And so there's arsenic and a lot of other stuff in that. So biochar can help that. And basically this is how it works. I'll break it down in the first 2 sentences here. Biochar is an indiscriminate bank. It has an extremely high surface area, and it doesn't care who you are. You can come, I'm right here, come on in. It's an indiscriminate bank for ions and proton charges. But the biology in the soil is discriminate. Plants and soil microbes do choose. I mean, I don't think they sit there and decide. I was kind of thinking, but they have, for whatever, in whatever mechanisms, they're able to selectively So what we find is that where biochar is put in the soil, it's not as though the arsenic is poof gone, but the arsenic that was in the soil is no longer showing up. I guess arsenic's not a good idea because I don't, because it kind of stays in there. But so I'm working on a project in California. California has cadmium, high levels of cadmium in a lot of really good soil areas. So right now I'm working with extension agents there. We're doing test plots and reducing the cadmium. And there's a bunch of research that already shows effectiveness, and we're just looking at my products and the price points and if we can make it all work. And what we're finding is that you put the biochar in the soil, you don't reduce the cadmium in the soil, but you reduce the plant uptake of cadmium. All right. Same with all kinds of hydrocarbons and organic compounds like pesticides and herbicides and certain heavy metals. That's shown well in this. They did a fungal. They did a soft rock phosphate. Right? So a lot of people in organic farming use rock phosphate. Rock phosphate has a lot of fluorine in it, which is kind of problematic. When the phosphorus is cleaved off, there's this extra fluorine cruising around. And sometimes that reduces the plant's ability to cleave off phosphorus, and so anyways, they tried mixing stuff with this rock phosphate, and what they found is that when biochar was mixed with the rock phosphate, it gave somewhere for the fluorine to stick to. First of all, the mycorrhizas or the fungi were able to have they had greater activity in cleaving the phosphorus and the fluorine. And once they did, the fluorine had something to stick to and was no longer causing such a problem, and the plants were able to take the phosphorus and go with it. So I think that's kind of a great example of biochar, this great surface area bank, kind of like other organic matters as well, being able to help to help kind of buffer the situation when you have nutrient dysfunction in soils. And I probably ran out of time here, so here it is. I broke it down to 3 things to remember because I probably just shoved way too much at you. So 1, biochar is a long-lived organic matter. When I say long-lived, I mean hundreds to thousands of years. Wood chips last a few years, biochar lasts hundreds to thousands. It is incredibly porous, which makes good housing for microorganisms. Nutrients and water bind to its surface in a way that they can be selectively pulled off by plants and microbes. That's about it. I see a question?
In your research, is there a particular plant that you partnered with, like you're carrying on removing a particular mineral or pesticide or whatever is in the dirt? Have you seen that?
Oh, like the cadmium problem?
Yeah,
well,
like
the problem
the dirt
is
plant.
these soils that have cadmium are great soils for growing lettuce, and lettuce is a great, it's a bioaccumulator of cadmium, so it's kind of a problem. But locally here, something that's really good news is that there's been no production since I stopped. There's been no production of biochar since I stopped. No commercial production of biochar since I stopped. And as of like this week, I've got 5 cubic yards of biochar available every single day at half the price that I was able to sell it to before.
So you're trying to revitalize the soils, what I'm about to get to my main question, and you're looking to try to like replenish the dirt. Is there a particular plant that you developed to remove certain things and then, not ingest it again, or is it okay?
I mean, the soils that are messed up are just kind of messed up. But biochar can help kind of at least make it less of a problem. But my big dream for Hamakua is like, we have very similar situations to the terracotta soils. We have tons and tons and tons of rain. You saw, like, add some charcoal and things working really good. We find a lot of it. So I'm imagining like, yeah, let's do it. Natural farming, biochar, let's make Hamakua awesome again. Yeah. Thanks, guys.
Aloha. I'm Dr. Dana Bogue, and I'm a nutritionist who turned into a horticulturalist because I came to realize there was a lot of studies that came out that showed how we had lost nutrient density from our foods. As much as 70% of some nutrients in our foods that are very important to our health had been lost over a period of just like 70 years. That might help. So I don't have to strain to get it out there, right? Okay. Can everybody hear what I just said? We're okay. Okay. Anyway, so the microbes are very important for making nutrients available to the plants so that it increases the nutrient value in the plants, the food that we eat. And so we're just focusing kind of on the microbes today. So something bad has happened to our food. So as I was saying, the food nutrient content has dropped greatly over the last 70 years. And actually, it was a problem even before that. It's just that these studies went back and looked at USDA databases, and they compared from back in the 1930s and 1940s up to like the present day, and they saw these huge drops. But even back in like 1930s, people were concerned about the lack of nutrient density. And a lot of doctors were saying, oh, you know, all my patients are having these nutrient density, or they're having nutrient deficiencies. Yeah. And so anyway, and it's just gotten worse over time. So there have been changes in our food system and in our agricultural methods that have caused this. We now have depleted soils. Depleted of what? Minerals, depleted of organic matter, depleted of good microbes. So, and we also have lots of what I call chemical sides. So fungicides, herbicides, insecticides. And the GMOs have just made things worse. Instead of going the other way, they genetically modify something so they can put more chemicals on. And those foods do have less nutrients too. So this is a really interesting chart. And it goes from about 1900 up to the present day. And it shows the drop of food nutrient density, like these different minerals dropping down. And that's come about a lot because of the mechanization of farming and adding chemicals of various types in GMOs with the glyphosate, which is, ties up nutrients. And then this chart is just an overlay of the first one, but it shows the people having all these different problems, like cancer and heart disease and things like that, and how that's increased. So decrease the minerals, increase the problems with health. So how do we increase food nutrient content? I do soil analysis for farmers and gardeners, and I do a very extensive analysis with like 18 different minerals on there and the pH, and I'll show you more about that in a little bit. And of course, the microbes, increasing the beneficial microbes, their diversity, and also the earthworms, making those nutrients available to the plants. And I do plant tissue testing. So like a leaf tissue test, so we can see what's going on with that growing plant and what it needs, and then we can actually do foliar nutrition sprays, and that's very fast acting. Helps those plants with their overall health and increases the nutrient density of the food. And then I go the extra step and I look at the final food and actually look at its nutrient density, compare it to USDA values. And that's like something in my book that my research. So for my PhD, I actually looked all the way from soil through the plant tissue and into human blood to see the effects all the way, which is really unusual because most universities just sort of pigeonhole everything. It's sort of like, oh, you look at the soil, oh, you look at the plant tissue, oh, you look at human health and human blood and such. And I said, no, I want to look at all the way to see how it affects. Anyway, so the bottom line is that we want to give our plants the correct amounts of everything they need to express their full potentials. And then hopefully, when we eat that food, we can express our full potentials. So we're going to just really kind of focus in on the microbes, since that's what Korean really brings about, the microbes. And so this is what we're going to kind of focus on today here with this talk. But we need lots of different kinds of bacteria and different kinds of fungi. See, all these tens of thousands of species should be there. And as I said, they make the nutrients available to the plants. They also do suppressing of diseases, and Ted was talking about some of that stuff. And you've heard also about the structuring of the soil, how they stop erosion. And some of them fix nitrogen from the air. And where do we get them? Compost, vermicompost, compost tea, inoculants of various types, including the IMOs. So I know some of this is a little redundant, but it's like maybe it'll sink in really well. Anyway, you can't manage what you don't measure. And so I took Elaine Ingham's course, and I bought the microscope that she recommended, and I do this work also. So I'll look at somebody's soil under the microscope and see, you know, what sort of levels and activity of bacteria, and also the levels of fungi that are there, and protozoa and nematodes too. Okay, so now this slide is just sort of showing like all these different elements that go into making some good food. And I think a lot of people sort of get pigeonholed in either, oh, it's all about the minerals. No, oh, it's all about the microbes. But I'm saying it's about all of these things, and the minerals are actually needed for the microbes to be healthy. You can kind of think of the microbes as little animals in the soil. So what do microbes need? Well, kind of like us, they need air, and they need water, and they need food, and they need housing. So like Josiah was talking about the housing and the biochar, right? And, you know, we're feeding them different things. So some of the things that they need are carbon and nitrogen. And depending on what kind of microbe they are, they like either more or less of the carbon and nitrogen. And we're going to have a slide later that talks about that. And then looking at mineral elements, the calcium-magnesium ratio is really important about the hardness of the soil. If you get too high of magnesium in comparison to calcium, you get very hard soil, a tight soil. And some say that this ratio is the most determining factor as to whether farmers are going to make money or they're not going to make money. So it's hugely important. And what I see, because I've done soil analysis all over the island, a lot of times the magnesium is much higher than it should be in relationship to the calcium. And so we do have hard soils. I can't hardly get my soil probe down into the soil sometimes because it's just so hard. And the sodium also hardens the soil. And I've seen that, especially if you're down near the ocean where you get those salt breezes that come through. Wow, it can be high in sodium, and it's really hard. And you also have water absorption issues. So I'm going to skip down to the next slide, and then I'm going to come back. I just wanted to talk about this ocean water, because I know some people like to use ocean water, and it's okay and it's good because it has lots and lots of different elements. But if your plants need the elements that it's supplying, because it is really high in sodium. I mean, look at this, how much sodium it has compared to something like calcium. And in your soils, you're going to need a lot more calcium than sodium. If you need sodium in your soils, that's great, you know? But you can also kill your plants by using too much of it. So that you have to be careful about that. And look at the chlorine, very, very high chlorine. You do need some chlorine, but you can also kill your plants if you put too much on there. Like chlorine typically is very hard on the microbes. It can kill the microbes. And that's why in organic, like certified organic, you can't use things like potassium chloride. It's not allowed. And it's hard on the soil. Now we're going to go back to that other slide, and we're going to finish up. Phosphorus, and this is like a soft rock phosphate. And Josiah was talking about this too, and the fungi really love it. And there are different kinds of soft rock phosphate. Some of them, I like the one that comes from Florida. It's called Calphos. It seems to be cleaner than some of the ones that come up from like Idaho and Montana, which can have heavy metals. So you don't want that. And then down here is molybdenum and cobalt. And most people don't soil test for these. They're pretty unusual, but they're actually needed by the microbes. So molybdenum is needed for the nitrogen fixation by bacteria, and cobalt is the central ion in vitamin B12. If you don't have these things in your soil, then you're not going to have the diversity of microbes. They're just not going to be there because they need this, and they can't live without it. So basically, you need to think of your microbes as little animals, and they need a large array of minerals. Okay, so high quality analysis are the key. And oops, here we go. There's lots of things that go into it, and I'm not going to go into each one of these because it's just too much to go into. They gave me 10 minutes. But there's lots of elements, and these are all on my soil analysis. And then I do the microbial analysis also and plant tissue analysis, as I said. And I interpret them for nutrient density, increasing the nutrient density in the foods. So that's the other thing. There's hardly been any research about increasing nutrient density. Most of the research is about yield, not about the food nutrient density. But I'm hoping to change that more and more. Anyway, so this is just an example of one of my tests that the soil report. It's 2 pages because I said it's got lots of things on it. And here is a chart that is going back to this fungi to bacteria ratio. And you can see here that different crops need different ratios of fungi to bacteria to work well. So the trees need a larger amount of fungi compared to bacteria in comparison to things like vegetables. So vegetables and row crops is more like 1-to-1, whereas your fruit trees, you need like 5 parts of fungi to 1 part of bacteria, or even more, depending on what it is. And the interesting thing about this is look at down here at the bottom, weeds, 0.1 to 1, which means there's a lot more bacteria compared to fungi. And what I see in soils when I do all these analyses is that I see most of the time we have bacteria but hardly any fungi. And no wonder they're having weeds, weeds, weeds. So by shifting that balance, you can change things. Okay, carbon to nitrogen ratios. Bacteria need a different amount than fungi, so the fungi need more carbon and less of the protein, whereas the bacteria need more protein. And this chart's and the other chart's in my book too. So, okay, so if you do things right, you are going to get increased nutrition. You're going to have better flavor because the plant can express all of its flavor compounds, and longer shelf life, and even changes in human blood glucose response, which is cool. This is one of my farmers. And you're going to increase your quality, decrease pests, increase yield, and increase viability, like economic viability for the farmer. In summary, managing your microbes, you want to get a microbiological test with the microscope. You want to use comprehensive soil mineral analysis. And then, of course, you're going to amend and fertilize according to the test results. Here's my book, which I did bring some copies today here. And I'm happy to say that it's made #1 in a couple of categories on Amazon. Okay, well, good. Oh.
Yeah, I recently heard about someone that was using lots of dolomite lime in their soil, and they actually put so much in their soil that they said that they had to sell it at farm.
Wow.
Because it would never recover from the amount of dolomite lime. And I guess maybe that has something to do with a little bit of magnesium that's in there.
Yes, that is true, and that's one thing that people tend to buy products that aren't good for their soil because they didn't test and they didn't have someone tell them. And sometimes I'll send somebody their test results and it says to use gypsum, which is calcium sulfate, and or lime, which is calcium carbonate, not dolomite, which has a lot of magnesium. It's like 20% calcium and 10% magnesium, which is a huge imbalance according to what you really need in the soil. And if you've already got too much magnesium and you put that on, you're going to have a real problem. And it happens. Epsom salt, that is high magnesium. It's magnesium sulfate. So, you know, I mean, some soils need magnesium, but what I see around here, most of them, it's more calcium they need, not magnesium.
Yeah, I was just curious if you put the difference between the seawater and the fermented seawater regarding the minerals in it.
I don't have a date on that. That's interesting. Yeah, it would be interesting to see what's what. So, I mean, if it's basically seawater and they've just added microbes, I'm not sure.
Yeah, they allow it to ferment overnight, but I'd be curious to see if there's a change in like the chlorine or sodium levels.
Yeah, I don't know. Well, the thing is, I mean, you're still getting some salt water there, right? So, and often I actually recommend that on my tests is use ocean water, but you're going to have to dilute it a lot. And, you know, it's whether you need it in your soil or not. That's the key. That's why we test. So we know exactly what to put on and balance our soil. And it's also balanced for the crop that you're growing. It's going to be different if you're growing fruit trees versus whether you want to pasture, for instance. Okay.